So here's a similar version of the question we did in class. I've tweaked it a little bit. You'll notice here that I've put kilometers instead of inches or centimeters, but it doesn't really matter what it says there. Really, that is all irrelevant. So there's two things going on here as we're actually bringing together two ideas. The first one being the Pythagorean theorem, PT as I call it. A squared plus b squared equals c squared. A squared plus b squared equals c squared. The other idea we're bringing together is the idea of similar triangles. Similar triangles. So, let's get started here. First of all, we have to find out if there are any similar triangles here, and if so, which ones are they? Let's label this actually A, B, C, D, and E. And we have to find this one. Actually, no, instead of this, let's use X. Let's make it a different color as a matter of fact. We have to find X. Oops. X. We have to find Y. And we have to find Z. So let's get my black back here. So first thing we can do is find out if there's any similar triangles. Now we see these guys right here. That tells us that it is, where's that highlighter pen? This tells us that these two lines are parallel. And that means that if this line is parallel and this line is parallel, then the angle here and here will be equal, and that's the AA rule. So since, actually, the fact that there's an angle here and then an angle here, that's in a small triangle, and then we have an angle here and an angle here in the big angle. So we have, since we have the angle-angle rule of two triangles, then these two triangles are similar because they have two angles that are equal. So therefore the third angle must be equal. So if all three angles are equal, they're similar triangles. Since AA, therefore triangle ABC is similar to triangle ADE. And remember that the order that we list these is quite important. So we've just shown now that we have some similar triangles, so that's good. Now we can move on to the next idea. If you take a gander at this, you've got one here, one here. This is a right angle triangle, so we should be able to figure this out here. And that's pretty easy because a squared plus b squared equals c squared. And don't forget that c is always the hypotenuse. I'll see if I can type that in there. So we know our value of a, which is here. So 1 squared plus 1 squared is the other side at the bottom, is equal to x squared. 2 is equal to x squared. X is equal to square root of 2. So let's write that in since we have that now, because that makes our lives easier. Because now we have this whole side here. We have 2, square root of 2 and square root of 2. So let's continue down here. I'll put a little line separating this. So here's the next part. Let's see if I can get down here. So what we're going to show here now, we have this whole side, And what we're going to do is, since we know that these two triangles are similar, we should be able to find this side, because we have we know this and this, so we should be able to find this, and we already know this, so it shouldn't be too much of a problem. Since we showed up there that there's the triangles are similar. I'm using a lot of short forms here. I hope that's okay. The triangles are similar, therefore we know that, don't forget A is up here, I can't see it. AB, the ratio of AB to AD is equal to AC over AE is equal to BC over DE. And don't forget that I'm always listing the smaller triangle sides up here and the larger ones at the bottom. Oh boy, we're running out of space here. I don't know how I'm going to do this. Let's see if we can go to full screen maybe. Whoa, that's not good either. Anyways, we're going to have to scroll down here. So let's see if we can squeeze it in here. We know AB. We don't know AD. We know AC. Yes, we do. And do we know AE? Yes, we do. If this is root 2 and this is root 2, 2 times root 2, because really it's root 2 plus root 2, right? Root 2 plus root 2 equals 2 times root 2. So let's put 2 times root 2 here. That cancels out. We get AD is equal to, sorry, that's incorrect. AD is equal to 2. Yeah, we cross multiply. 2 times 1 is equal to AD. Yeah, oops. So AD, let's make that a little bigger so we know that that's an A. AD is equal to 2. So let's write it in since we know it. That's in there. So we already found this one. We already found this one. That was the first one we found because we knew this and this. We just found this one, and now we're going to continue on, and there's two ways of doing this since we know this whole side here now. Actually, hold on. AD is equal to 2. This whole side is equal to 2. Therefore, we can't really say that y is equal to 2. Y is equal to 1. Because if this whole side is equal to 2, this is equal to 1, this must be equal to 1. So the last thing we need to do is find DE. So we have 1 here and 1 here, that's 2. That whole side is 2. Here we have root of 2 is 2 root 2. So we could use Pythagorean theorem also to find that, or we can use similar triangles, whatever you prefer. We cancel that out. Now, what we want to do is start with this side here so we can get this side. So if we go 1 is to 2 is equal to, now we're going to look at this one as 1 is to z. So the ratio of this to the whole side is equal to the ratio of this to this whole side, which is that. Clearly see that z is equal to 2. And we put our 2 in, and we've answered all our questions. Now, one thing I want to mention here is you'll notice, because this is an equilateral triangle with a 90-degree here, and these are similar triangles, if this is 1 and this is 2, basically, to get the bigger triangle, I'm multiplying by 2 all the time. So if this was 1, this was 2. You'll notice this was root 2 for up to here. Multiply by 2, it's 2 root 2. And if you take this and multiply by 2, you get 2 down here. So really it's almost like we're multiplying each side. Well, that's what those whole ratios do. We're multiplying this side by 2, this side by 2, and this side by 2 to get the larger side, this side, and this side.